Welcome back to the lecture series of Electronics, Measurement and Instrumentation. In this lecture, I am going to discuss about RF emitter, that is also called thermocouple. So the thermocouple is nothing but a junction of two dissimilar wires, and this junction is chosen in such a that a voltage is generated by heating the junction, and the output of this RF emitter or thermocouple is delivered to a sensitive DC micro emitter, and this particular device thermocouple is calibrated in such a that it can be used for the measurement of AC current in a radio frequency range. See, this calibration is made with DC or with low frequency such as 50 cycles, and applies for all frequency for which skin effect in the heater is not appreciable. Thermocouple instruments are standard means for measuring current at radio frequency. The generation of DC voltage by heating a junction is called thermoelectric action. It means this phenomena is called the phenomena of generation of DC voltage by heating a junction is called thermoelectric action, and device is called thermocouple. There are different type of the thermocouple. So in a thermocouple instrument, the current to be measured is used to heat the junction of two metals. These two metals form a thermocouple, and they have the property that when the junction is heated, it produces a voltage proportional to the heating effect. This output voltage drives a sensitive DC micro emitter, giving a reading proportional to the magnitude of AC input. The AC current hits the junction. Heating effect is the same for both half cycle of the AC, because the direction of the potential drop is always be the same. The various type of thermocouple definition are as follows. See, there are different type of the thermocouple junction. This particular first diagram is called the mutual type thermocouple. In this mutual type thermocouple, AC current is directly passed through this thermocouple, and this particular thermocouple is connected in shunt with the emitter. So that is basically a disadvantage of using a thermocouple that is directly connected in shunt with the emitter. Then there are a second type, and see this particular diagram 3.6b, it is called a contact type thermocouple. So in contact type thermocouple is less sensitive than the mutual type. The contact type, there are separate thermocouple leads. See here, there are a separate thermocouple lead and a heater. So its sensitivity, it is less sensitive in comparison to this mutual type coupling. So then the third is called a separate heater. See here the heater, then there is a glass bed, and then we have emitter. So what is the advantage of this separate heater? Thermocouple is held near heater, been insulated it by a glass bed. This makes the instrument sluggish and also less sensitive because of temperature drop in the glass bed. The separate type is useful for certain applications like RF current measurement, because here their sensitivity is affected due to the glass bed. To avoid loss of heat by radiation, the thermocouple arrangement is placed in a vacuum in order to increase sensitivity. Then the fourth, that is the most practical type of the thermocouple is bridge type. See here a bridge, it is a balanced bridge, and this one junction is work as a thermocouple. This is the high sensitivity of the mutual type, and it avoid the shunting effect of the micro emitter. It means first its shunting effect is avoided, and sensitivity is as high as that of the thermocouple. The sensitivity of the thermocouple is increased by placing it in vacuum, since loss of heat by conduction is avoided, and absence of oxygen permits operation at much higher temperature. So these are the advantages, so that it is better we use thermocouple in vacuum environment. A vacuum thermocouple can be designed to give a full scale deflection of approximately 1 milliampere. A similar bridge arrangement in air would require about 100 milliampere. See, the range of the current required, if we are using a vacuum, we required 1 milliampere of the current, but if we are not using the vacuum, we required 100 milliampere of the current. Then the material commonly used for thermocouple are constantan against copper, magnesium or platinum alloy. Heating element of open air heater is typically a non-corroding platinum alloy. Carbon filament heater are used in vacuum type. It means in non-air type, in non-vacuum type we are not use carbon filament. Thermocouple heater operates so close to the burnout point under normal condition that they can sustain only overload without damage, commonly up to 50%. This is one of the limitation of the thermocouple instruments because it's not able to control overload. Commonly used metal combination are copper constantan, iron constantan, chromel constantan, and so on. So these are the thermocouple, and then we are moving toward to the limitation. So limitation of the thermocouple is overload, small overload. A rise in temperature cause change in resistance of the heater. Presence of harmonic changes the meter reading because the heating effect is proportional to the square of the current. See this, the heating effect is proportional to the square of the current. It means under root I1 square, I2, I3, I4. So I1 is the fundamental, I2 second, I3 third. Then see this particular example to understand what are the limitations. If the 20% harmonics are present, then I2 equal to 20% of the I1. So it means I2 equal to I1 upon 5. So therefore, if you put I2 equal to I1 upon 5 and I3, I4 is equal to 0, then it's, see here, it's become I is equal to I1 plus 0. It means it's become I1 plus 0.02 I1. It means this particular 20% harmonics is present, it's have 0.02. It means 2% of the increase in error. That effective value I equal to I1, but it is I1 plus 0.02 I1. And this 0.02 I1 is present due to this 20% harmonics. And 20% harmonics is a small number. 20% is a very small number, but it can increase the error in current measurement is about 2%. Just 20% harmonics in the present in the current increase error in the measured current of 2%. So that is the basically limitation of the thermocouple, and harmonics will also affected the working of this thermocouple. Then we use frequency calibration so that this particular device is used for radio frequency measurement. So the first is effect of frequency calibration arises because of the various factors. So the first factor is skin effect that cause higher reading at higher frequency, especially if heater wire is small. A low current instruments with circular cross section used in vacuum may have a skin effect error of less than 1% of frequency. Ribbon heater are often used for large current, but they have larger skin effect. Solid wire and better still hollow conductor are ideal with a view to minimizing from skin effect. It means to minimize the skin effect, we require solid wire or better still hollow conductor a hollow conductor types of heater is required. Calibration done with DC or low frequency such as 50 Hz, for which skin effect of the heater is not appreciable. Accuracy can be as high as 1% for frequency up to 50 MHz. For this reason, thermocouple instruments are classified as RF instrument because it is we are able to measure current in the frequency of 50 megahertz, and this 50 megahertz comes in the RF range, radio frequency range. That's why it is called radio frequency instruments. Above 50 megahertz, skin effect force the current to the outer surface of the conductor, increasing the effective resistance of the heating wire and reducing instrument accuracy. For a small current up to 3 ampere, the heating wire should be solid and very thin. Above 3 ampere, heating wire should be hollow and tubular in design to reduce the skin effect. So that is this all about the skin effect. To minimize the skin effect, we don't use the ribbon type of wire, we use solid wire, we use hollow conducting type of the wire. So these are the effect. Then next is non-uniform distribution of the current. That can be also occurs at the high frequency. The current distribution is non-uniform due to the heater length, because at high frequency the length of the heater is proportional to the wavelength of the frequency. Then the current distribution along the heater is not uniform and the meter indication is uncertain. Hence, to avoid this, heater length and associated leads should be less than 1/10 of the wavelength. That is one of the because spurious capacitive current. These occurs when thermocouple instrument is connected in such a small manner that both terminals are at potential above ground. As the frequency increase, a large current flow through the capacitance formed by thermocouple lead with the meter acting as one electrode and ground on the other. To avoid this, proper shielding of the instrument should be provided. The calibration of thermocouple is reasonably permanent. When calibrating contact and mutual with DC, it is always necessary to reverse the polarity to take the average reading. During the calibration we take this precaution. Contact is contact and mutual calibrating contact and mutual, it is always necessary to reverse the polarity to take average reading. This because of the resistance drop in the heater at the contact may cause a small amount of DC current to flow. Reversing the calibration current, averaging out these effects. So that is all about the RF emitter. So thanks for your kind attention.